This video is about converting between decimals, fractions, and percents and finding simple probabilities. So first of all, we need to know what probability is. So the probability is the likelihood an event will happen. When we're looking at probability, we can express it in three different ways. We can do it as a fraction, a decimal, or a percent. So first we're going to talk about how to convert them from one form to another. So in the first two, we have a fraction, we need a decimal and a percent. So to get our decimal, we can just take our fraction and divide in the calculator. So 1 divided by 6. We're going to round to the nearest thousandth, which is 3 places. So we have 1, 6, and then the 6, but the 6 after it rounds it up, so it'd be 0.167. Then to get to a percent, in our calculator, we can either multiply by 100, or we can move our decimal place 2 places to the right. So this would become 16.7%. Our next one is 3/8. So 3 divided by 8 gives us a decimal of 0.375. When we move our decimal 2 places, that would become 37.5%. Next, we have a decimal. So with the decimal, we can move 2 places to the right to get our percent is 20. To get our fraction, we can put 0.20 into the calculator and then hit math, enter, enter, and it'll give us our fraction of 1/5. In the next one, we have 1.23. So if we move the decimal 2 places to the right, that's 123%. Sometimes we will have percents over 100. To get it as a fraction, we would take 1.23 math, 1.23 math, enter, enter. That would be 123 over 100, and that's our reduced fraction. So when we have our percent, we can turn that into a decimal by taking the decimal and moving it 2 places to the left. So this would be 0.28 or 0.28. To get that as a fraction, we put 0.28, math, enter, enter. So that would be 7 over 25. We also have 150, which if we move over 2 places, that becomes 1.50. In our calculator, 1.50 math, enter, enter, would get us 3 over 2. When we're looking at probability, if an event is absolutely going to occur, then we're going to say it has a 100% chance for a 1 out of 1. Sometimes we hear that percents are also more than 100. So even though we will have a calculator with us most of the time, it is helpful to recognize some of these and their decimal and percent equivalent. Third, that is 0.333 as a decimal, which would be 33.3%. 2/3 is 0.667, which is 66.7%. 1/4 is 0.25, which is 25%. 1/2 is 0.50, which is 50%. 3/4 is 0.75, which is 75%. 1/5 is 0.20, which is 20%. 2/5 is 0.40, which is 40%. 3/5 is 0.60, which is 60%. And 4/5 is 0.80, which is 80%. So when we are doing probability, we are looking at the desired outcomes out of the total number of outcomes. So let's look at some different examples of probability. So in number 1, find the probability that a randomly chosen friend is a Cubs fan if 8 friends are Cubs fans and 4 friends are White Sox fans. Write your answer as a simplified fraction, decimal, and percent. So if we have 4 and 8, that means there are 12 people possible, and 8 of them are Cubs fans. If I take my calculator, 12 divided by 8 math, enter, enter. My reduced fraction is 2/3. So 2/3 then as a decimal, 2 divided by 3 would be 0.667, which would be 66.7%. Number 2, there's a bag of 20 marbles. So this is how many total marbles there are. 5 are red, 8 are blue, 3 are green, and 4 are yellow. Write the probability as a fraction, decimal, and a percent. So what's the probability that it is red? Well, there are 5 red out of 20 total marbles. So 5 divided by 20, math, enter, enter. That reduces to 1/4. 1 divided by 4 is 0.25 as a decimal, which would be 25%. B, the probability that it's green. So there are 3 green marbles, so we have 3 out of 20. 3 divided by 20, math, enter, enter, is already reduced. So we would get our decimal by doing 3 divided by 20. We get 0.15, which would be 15%. In C, we want to know yellow or blue. So there are 4 yellow and there are 8 blue. So we want to add those together. 4 plus 8 gets us 12. So we have a chance of 12 out of 20 to be one of those 2 colors we want. 12 divided by 20, math, enter, enter, reduces to 3/5. So we have 3 divided by 5, which is 0.6, so 0.6. So as a decimal, if I move this over, I don't have a number there, so I would put a 0, so this would be 60%. And then what's the probability that it's not blue? So if there are 20 marbles and 8 of them are blue, that means we have 12 that are not blue. So we would have 12 over 20, which we saw in the last problem, reduces to 3/5, which is 0.6 as a decimal, so 60%. In number 3, a group of students is asked their favorite color, and the results are in the table below. So we have red, blue, green, orange, and purple, and we have the number of all of those results. So how many students were polled? So we want to add them together. 32 plus 40 plus 28 plus 27 plus 23. So when we add all of those together, we get 150 students. So what is the probability that a student said orange? Well, there's 27 that said orange out of 150. So 27 divided by 150, math, enter, enter, would be reduced to 9 over 50. If it doesn't tell you that we have to put it in decimals and percents, we're just going to leave it as reduced fractions. So in C, what's the probability that a student said red or blue? So there's 32 that said red, and there are 40 that said blue, so that's a total of 72 students out of 150. 72 divided by 150, math, enter, enter, and that is 12 over 25. What's the probability that these students said green? So there are 28 green out of 150. 28 divided by 150, math, enter, enter, would be 14 over 75. What's the probability that a student did not say purple? So if we go back up to the table, we see 23 did say purple. So out of the 50 students, we're going to subtract 23. So when we do that, we get 127 students picked a different color. So 127 divided by 150, math, enter, enter, is already as reduced as it can be. Number 4, Warren hosts a girls' volleyball camp over the summer for only freshmen and sophomores. Of the 120 girls that attended, 75 of them were freshmen. Of the freshman volleyball players, 30 of them played another sport as well. Use this information to find the probabilities as simplified fractions. So what's the probability that they were a sophomore? Well, if 75 of them were freshmen, we can do 120 minus 75 to get that 45 of them were sophomores. So we have 45 over 120, and that reduces to 3/8. To find the probability of them being a freshman, there were 75 that were freshmen out of 120 volleyball players. So 75 divided by 120, math, enter, enter, and that gets us 5/8. So looking at just the freshmen, where there are 75, how many of them play another sport? So we had 30 that play another sport as well out of the 75 freshmen, because we're only looking at freshmen in this problem. So that reduces to 2/5. And then what's that they only play volleyball? So if 75 are freshmen, 30 of them play another sport, that means 45 do not. So we have 45 divided by 75, and we get 3/5. Now, when you are converting a fraction, you can either get to a decimal and then hit math, enter, enter, or you can do it right away, and you'll still get the same answer. So we still got 3/5. In number 5, cards have 4 suits: clubs, spades, hearts, and diamonds. Write the probability as a fraction as a decimal. So, a couple of things about cards. There are 52 cards. There are 26 that are red. There are 26 that are black. There are 13 clubs, 13 spades, 13 hearts, and 13 diamonds. So what's the probability of pulling a heart? So there are 13 hearts out of 52 cards. 13 divided by 52, math, enter, enter, is 1/4, which is 0.25 as a decimal. Probability of pulling a spade is the same thing because it's 13 out of 52, which reduces to 1/4 or 0.25 as a decimal. What's the probability of it being a red card? So there are 26 red cards out of 52. So 26 divided by 52 is 0.5, which is 1/2 as a fraction, and then 0.5 as a decimal. Heart or club, so there are 13 of each. That means 26 total out of 52. So just like the red, it reduces to 1/2 and 0.5 as a decimal. Number 6, during a football game, Warren threw on 4 of its last 6 plays. What is the probability that they will not throw? So if they threw on 4 of 6, that means they did not throw on 2 of 6, and that reduces 2 divided by 6, math, enter, enter, as 1/3. Number 7, a total of 48 families with pets were polled. 34 families had dogs, 20 families had cats, and 10 families had fish. So if we look at these numbers, we see that they would add up to more than 48. How is that possible? Because families could have multiple pets. So what's the probability that they have a cat? So there are 20 cat families out of 48. So we can do 20 divided by 48, math, enter, enter, and that reduces to 5/12. What's the probability that they do not have a fish? So if 10 of them have a fish, that means 38 do not. So 38 divided by 48, math, enter, enter, and that reduces to 19 over 24. What's the probability that they have a dog? There are 34 people with dogs out of 48 families. So 34 divided by 48, math, enter, enter, gets us 17 over 24. For our last problem, the math team stops at Subway on their way to a big math team meet. The following graph shows the sandwiches choices of each student. Give the answer as a decimal rounded to the nearest hundredth and as a percent. So if we look at the math team, we have 3, 4, 7, 10, and 14. So we need to add those together to figure out how many total students went to eat at Subway. So we have 3 plus 4 plus 7 plus 10 plus 14. That gets us 38 students. So what is the probability that they ordered a chicken sandwich or chicken salad sandwich? So a chicken salad sandwich, there were 4 out of 38. We want that as a decimal and a percent. So 4 divided by 38 to the nearest hundredth is 0.11, which would be 11%. What's the probability that they chose a turkey sandwich? So we have 14 out of 38, which would be 0.37, so 37%. What's probability that they did not choose a ham sandwich? So 7 of them picked a ham sandwich, which means 31 did not, because we have 38 minus 7 is 31. So we have 31 out of 38, which is 0.82, so 82%.